This video is going to have a look at how to reconstruct a piecewise graph that consists of three separate equations. So a piecewise graph is a continuous graph that is formed by two or more linear graphs or linear lines that are joined by points of intersection. So let's have a look at an example of how to construct a piecewise graph. So in the example, we want the following three equations to make a piecewise linear graph. The first equation is y equals x minus 1. The second equation is y equals 2x minus 1. And the third equation is going to be y equals negative 3x plus 4. Now, if we have a look at our domains, we can see that we haven't been given the domains, so we've got to go ahead and calculate our turning points. Calculating the turning points will help us to identify our domain values and help us to graph the piecewise graph. So because I've got three equations, I'm going to have 2 points of intersection. So I'm going to calculate the first point of intersection by having a look at the first two equations, and I'm going to solve them simultaneously to be able to identify my turning point. So to solve them simultaneously, I want to equate the two equations. So x minus 1 equals 2x minus 1. So then minus 1 is going to equal to x minus 1. When I move the minus 1 over the other side, it'll be a plus 1. So 0 is equal to x. With that x is equal to 0 value, I can substitute it into one of the equations to find out my y value. So y is equal to x minus 1. So y is going to be equal to 0 minus 1, which is equal to negative 1. So my first intersection point between my first two equations is going to be 0 and negative 1. So that means when x is smaller than 0, the equation is going to be y equals x minus 1. So to go ahead and work out my second intersection point, I then need to look at the next two, so the second and the third equations, and do the same process and solve them simultaneously. So to solve them simultaneously, I can equate the two equations. So 2x minus 1 is equal to negative 3x plus 4. So moving the negative 3x over, it'll become 5x minus 1 is equal to 4. When I move the negative 1 over, it'll be 5x is equal to 5. So therefore, x is equal to 1. Knowing that x is equal to 1, I can go ahead and determine my y value. So y is equal to 2x minus 1. So y is going to be equal to 2 times 1 minus 1. So y is equal to 1. So my second turning point is going to be positive 1 and 1. So for my second equation, y equals 2x minus 1, it is going to be that equation on the graph between 0 and 1. And then when x is bigger than 1, it's going to be the third equation of y is equal to negative 3x plus 4. So now that I've got my domains and I know my intersection points, I can go ahead and graph that onto the Cartesian plane. So my first equation is going to be y is equal to x minus 1. My second equation will be y is equal to 2x minus 1. And my third equation is going to be y is equal to negative 3x plus 4. The first step in graphing, once I know the intersection points, is to mark them onto the Cartesian plane. So 0 and negative 1, and 1 and 1. So after I've done that, I can go ahead and add in my three lines. So my first line, y is equal to x minus 1. That means it has a gradient of 1. So using my gradient of 1, because I'm working backwards, I'm going to go back 1 and down 1. And then once I go back 1 and down 1, I can put in a dot. I can do that process again a couple of times. So backwards 1, down 1, backwards 1, down 1. Once I have a few dots, I can go ahead and draw in my line. And because there's no endpoint in my domain, it's just x is smaller than 0, I can put an arrow on the end of my line. For my second equation, I've got a gradient of 2, but I've also got my two intersection points marked, and I can just draw a straight line between those intersection points. If I wanted to work out the gradient, I could apply my gradient of 2, so over 1 and up 2, and that is going to be correct. So now to finish off my piecewise graph, I can mark in my third equation, and that third equation has a gradient of negative 3. So gradient of -3 means that every time I move over 1, I go down 3. So applying that over 1, down 3, and mark it as a dot, over 1, down 3, mark it as another dot. And then once I have a few dots on my graph, I can go ahead and draw that straight line. And again, because there's no endpoint in my domain, I can put an arrow, and that is my completed graph. So at this point, we can do a quick common sense check to make sure that the graph looks correct. Looking at my gradients, I've got 2 positive gradients and then a negative gradient for the third equation. So my piecewise graph, I'm going to have my first section and my second section having a positive gradient, so sloping upwards. And then my last equation, the section in red, has a negative gradient, so that is sloping downwards. So my graph matches what the 3 equations should be. So that is an example of completing a piecewise graph when we have 3 equations.